Now that we are done with basic manipulations on variables, let's start with some basic expressions and conditional statements. So let's remove this first, and let's start with creating a variable. Or, well, let's use let because we'll be reusing, I don't know, let's use const. So arithmetic expressions are done intuitively in JavaScript. We have already done saving a value to a variable where the variable is always on the left hand side of the equation, like in this example. Now we can also do addition. So like in this example, x plus 1. We can also do subtraction, like in this example, or minus 5, or even, well, yeah, 5. We can also do division, like a is equals to y over z, and we also can do multiplication. So let's have y times z, as well as modulo, where it means we just get the remaining given a division. So like c is equals to y modulo z, and then save it in a variable. Now we can also do shortcuts, like let's have d is equals to 1. We can do d plus plus to do addition of one variable, no, not one variable, but one value. And we can have this as well, where d plus equals 5, meaning it's equals to d is equals to d plus 5, and so on and so forth. And we can do a minus decrease by 1, and as well as this one as well. So for let's just try if it works for so that we can see if what we did was correct. So let's save it, we refresh it, and as you can see, we have done the correct expressions for doing addition and subtraction, as well as other arithmetic expressions. Now for conditional statements, they are actually in the form of true or false. That means if it's true, then it will return a true value, and if it's falsy, it will return a false value. So for example, if I do this, and I have this, we will have if and I do this, it will return true, even if one is a string and one is a value, because these are similar statements. But if I do this triple equal sign, it means that it's false, because one is a string. Even if they have similar values, one is a string and one is a integer. So it has to be both types as well if we're going to do this. And this is the a safer way of doing conditionals or comparisons between values, because we know that it's exactly the same value and type as well. We can also do, let's say, a not sign. So that means If we do this, it becomes false because they are similar, so that means it's not it's actually false statement. And if we do this, it becomes true because these are not really similar, or these are not really equal, so this becomes true. Of course, we have, like, let's say 7, and we have it as less than. We know that this is true. And if we do less than or equal, it of course is true as well. If it's greater than, we know that this is false. And let's just say we put it as 5, and we did a greater than or equals, it becomes true. So those are things that we can use. Let's also do, like, if this is false, we can reverse x by just adding an exclamation point at the start. It becomes true. And again, if we do double quotation, double exclamation point, it becomes false. So that means a double exclamation point with x is equals to x. And as you can see it in here. As you can see, conditional statements will always return a Boolean value. Take note when it comes to strings. So string and const y is equals to string. These two are equal because they are of similar characters in terms of even the case. So if one is uppercase s and the other is lowercase s, it becomes false. So take note of that when it comes to comparing two strings. As for objects and arrays, so if I did this 1, 2, and 3, and I also did this, this is false because these are, even if the elements inside are of same value, they are of different objects or different references to an array. So that means if I did this, because the reference of the array in x is now equal to the reference of the array in y, this becomes true. So you need to be careful when it comes to arrays, and as well as objects. They are also of the same thing. Now, given that we know how to do conditions, we can now use the if then else. If something, then do this. So if condition, then do this, else do this. So this is the normal setup for a if then else. So let's say x equals 5, then we just replace this with x equals let's say 5, then console.log x, or maybe then console.log else. So if we run this, of course, what it will print out is then, and if we change it, making it a false statement, it will print out else. So that's the very sort of easy way to do. When it comes to like if then else, we can also remove the so let's just add console.log end. So that means we have else and end, and if it's 5 again, it should be then and end. Now after that, We can also remove else. Sometimes you don't need the else part. So if we do this, this is then. If we have a different value, we have end only. It means that it will not do the then part. So that is something. Now, sometimes, let's say we want a value that is put here, and let's say we have another thing here like 5 given this, let's say if y is equals to 5, let's have x equals to y, else x is equals to 1. So if we do this, it's perfectly fine, 5, and if it's like a different number like 2, we'll get 1. But the better way of writing this one is, instead of having let, we can use const x is equal to the condition itself, and if it's true, so if it's true, we will return the value of y to x, or else we will return the value of 1, and we can remove this. So again, oops, we have double instantiation. So again, it's 1 because 2 is not equal to 5, but if we have it equal, we have this one. So in essence, we have just created a ternary expression. Ternary expression. We can also do if then else chaining. Chaining. So let's say const equals 5, if and then maybe if x is less than 5, console then 1, and then we do else if x is equal to 5, console dot log then 2, else if x is greater than 5, console dot log then 3, and so on and so forth. Else console dot log else. So if we do this, this is chaining, because it's equal to 5, it's then 2. If we do 2, it's then 1. If we do 6, it's then 3. And if we want to have an else, maybe null. Oh, it's because less than 5. None, I guess. Let's see if it works. Yeah, none is not 5. It's not equal to 5. It's not less than 5. It's not even greater than 5. It's a different value, and that means it is else. So we can do this kind of thing, but if we are saying, like, let's say if we are doing like this, x equals 1, x equals 5, and x equals 6, and we break, we can of course expect it to be like this, but there's also a better way using switch, where you add the x here, and then if it's a case of 1, we do a console here, we add a break, should always add semicolon on this one, then case 5, and then case 6, console.log, then 3, then break, and default is console.log else. So again, it will be the same if we do this. So as you can see, it printed both the top switch and the bottom one. If we remove break on this one, it means that if this will be the one equal, but because there's no break, it will go spill over the next case, as we can see here. So that's one of the caveats when you are using the switch. Now, given that we already know how to do if then else, we can now go to loops, because loops also are able to use conditional statements to know if they are going to still do the code inside the loop or not. So we can, like, let's say here, as long as it's less than 10, it will do the loop inside. And let's just have console.log I, console.log I, and then I++. And so if we do this, we can see, let's have a smaller number, let's say 5. We can see this set of numbers. We can also start the do while command, less than 5, and still go for it. As you can see, so let's restart the value. It's equals to j is equals to 5. This is j, not h, j. So as you can, why did I start on 5? 0. So we can see 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. The thing is, if I have it like greater than 5 already, we can only see one number, and it's printed on the do while instead of the while, because while checks first if the condition is true. If it's true, then it will do the code inside the loop. And because in this example, I is not 5 is not less than 5, it will not do the loop inside the while. But in this case, it does the loop first before checking. And given that 5 and which is added by 1 here, it becomes 6. 6 is not less than 5. It will stop the loop, but it will do the loop first. So that's how while works. Now, as you can see here again, we are doing this kind of setup, but if we are using for loop, we can do the same thing, where we instantiate the value. So this is the instantiation or setting up the variable. So we are setting up the variable here. Set the variable, then conditional statement. So we are actually doing this, and the increments. Oops, we are using not I but j and j++. So this is increments as well as increment. Let's remove this one. Yeah, and that's how we set up the loop. And this is the loop body. So here we are, knowing how loops work. We do this again, we get the same value. 0 1 2 3 4 0 1 2 3 4. Okay. Now, when it comes to array, so let's delete this. Array is equals to 1 2 3 4 5. Let's add some spaces for let's have different numbers. 3 4 5 33 2 4 5 43, and so on and so forth. Now we can do this to be able to iterate over the values inside. We can of course do let I is equals to 0. I is less than the length of the array, and then I plus plus. Then we can do the I element and the value, which is the array, the array. So as you can see here, this is how we have set up the array itself. But there's a more intuitive way of doing this. It's using const element of array using the off, and from here we can just get the element itself as seen here. But what we need is, if we need to also get the index, we can do this, where we do a destructuring of a pair of index and value of an array that we will transform into entries. Then we can also do the same thing. So instead of I, it becomes index, and instead of array, we do this, and you can see it back here. Now you might be asking, why am I using const instead of let? While in here let is used because we know that we will change the value of I inside the loop, or actually in this area. Why are we using const? The thing is, remember on this one, this is the scope of that particular iteration only. So that means the array, or I mean the element inside the array, will be put in this variable, and this variable will not change in this scope only. While in this example, the I is changing. So like if I do a const here, let's see if it will work. You can see that the assignment to a constant variable is fired, because we are actually changing the value of I here. We are just it sort of in hindsight, it sort of happens like this, where you have a let I equals 0. So this is what's happening above. Remember, let I equals 0, and then while I is less than array.length, we do a console log. We do this, and then we do I++. So this is what's happening here, but for this setup, we have in essence we have something like this. We still have something like this setup, but instead of like setting it up here, there's a const element is equals to array I, and that is what we are using. That is what we are using for this one. So these things are not how do I say this? These things are not accessible. While this is the only one that is accessible, which is the const. And when it comes to like scoping, the life cycle of that variable will only happen in this scope. While in this one, we have the whole let as the variable that we are using. That's why we need to have, for I, we have the whole variable I that we need to use, and that means we need to change the value. So that's why we are using let. Now that is for off option for off. For array array manipulation, or array iteration, we can also use for each, which we can add a function the same way. We get the element first, and we do this. So if we run it again, this is the one we can do the for each, and the other is if you need the index, that's the second parameter that is being sent to a for each. As you can see, we are able to use for each as well. We have already done map and reduce before, so I will not talk about it here. When it comes to objects, there are several ways. So let's have obj x1, y2, z is 5. If we are going to iterate an object, of course, we can use, let's say, object dot keys to iterate over so let's just use keys here to make it a little bit more readable. Again, we can do this, and then for values, we can have values of an object, and then for const value of values, can do this. Oops, sorry. And lastly, we can also do this. So once we are done with that, we can get the key value pair of entries, and then we just do this. And so we refresh, you can see these are the keys. You can see here, these are the keys, these are the values, and these are the key value pairs. We can also do the in function. So you can get in of obj and get the value of that property and do this. Like so. I just want to add two more keywords that will help complete our discussion on loops, and that is break and continue. So I'll just use the last one as an example. So like, let's say if key is equals to y, then we need to break. So what does it mean? So you can only see x1 here, and it will not go to y2 and z5, because it means if it's already y, the key is already y, then we will need to break out of that loop. But if we do this, continue, you can see that the y was skipped, because once they see the continue, or the code sees a continue, it will not do the code below but go back to the start. So those are the two things that you'll need to also know when it comes to loops. Now that we are done with expressions, conditional statements, and loops, let's go to functions.